When facing the challenges of AMS 2750 or CQI 9 with regard to temperature uniformity survey, one of the critical requirements and things you need to focus on is the important reporting requirements laid down by both standards. If you see on this slide, we've taken a section from the AMS 2750 standard 35516. It clearly indicates all of the necessary information you need to include in your temperature uniformity survey. It's important that these are addressed to make sure you don't have any non-compliances when it comes to any audits as part of NADCAP. The Thermal View survey software has been developed with this in mind, and therefore we've tried to address all of the requirements of the standard within the reporting capability of the software itself. On the screen you'll see the various content pages of a full report that the software can generate, which means you are fully compliant to the standard. Page 1 is the full TUS and furnace setup parameters review page. The second page is the graphical TUS results showing you where the TUS levels are and the actual fitting of the TUS zones to the TUS levels. 3 is the schematic of the TUS frame showing you where the thermocouples are positioned. Page 4 and subsequent pages would be the results of the respective levels that you're performing your TUS at. So a full summary of all of the necessary maximum, minimum differences and tolerance data associated with the analysis of the TUS. Also included in that is all the full TUS temperature data that complies with the data collection requirements of the standard. Page 6 and 7 will give you the full details of the data logger correction factor files that have been applied, if they have, and also thermocouple correction factor files, showing you all the correction factors at the respective calibration points, but also the TUS levels that have been used in the TUS itself. Last but not least, there's the audit trail, which shows you all of the steps that have been taken as part of the process, as and when correction factors are applied or removed, etc. So you've got full compliance to the standard itself. So how do we go about creating a report? Within the software, there's been a lot of work put into creating a fully controlled and easy to implement set of steps you need to take to complete the full report. Each and every one theoretically needs to be incorporated into the report to get full compliance. Within the software, if you go to the menu bar and we find Print TUS Report, if you click on that, the dialog box will come up with all of the necessary fields that need to be completed as part of generating that compliant report for your TUS routine. You'll notice that some parts of this dialog are in white, which means these are manually filled in by the user, and each item is listed against the requirements of the standard. The sections that are in grey means it's data that's taken directly from the TUS itself. So it could be the calibration data for the logger. It's going to be the raw data that is being input from the TUS results itself. So it's a combination of information taken directly from the hardware or the software as it's been set up, the files that you're using, and manually input information that describes the way in which the TUS was performed, and all the necessary complementary information that needs to go alongside that TUS data to give you the full picture of what's been performed. The second page, there is a little bit of flexibility. You can actually put your own unique notes in. There's a notes section, but there's also a additional details field. This is where you can actually create a header or for a particular parameter you want to report on a regular basis. You give the title and then you could put in a unique manually input value to complement the test that you performed. At the end of the report, we can either create the report by simply pressing the Create Report button, which shows you the pages on the software screen, which you can then print to a printer. Alternatively, you can create a PDF of the report, which then can be saved, archived, and even sent to somebody else for review if necessary. Obviously, with the amount of information that has to be input into the report to make it compliant, this can take a lot of time. As a result of that, one useful feature we've incorporated into the software is the ability to save a report template. So for instance, if you've got a furnace that you're going to regularly be surveying on a monthly basis, for instance, or every quarter, you don't want to be putting all of this manual data back into the report each and every time you do the run. So what we allow you to do is, having input the data for the first run, maybe the initial TUS or the first periodic TUS, you can save this template. And what that does is it saves all the manually inputted information that may be consistent from run to run. Next time you do your TUS, you can then recall that report, and it will automatically populate all of the note sections, the actual sections that include things like control instrument tuning constants, which may be constant. You may need to edit these subtly, but it at least gives you all of the information that you can subtly edit and saves you significant time. So next time you do a run, all you simply have to do is download the data, open up the report function, and you then go to load from template. You pick up the template file specific to the furnace or the TUS you're performing on that furnace, and you recall that information. Obviously, you're going to name it unique to the process or the furnace that you're performing. So that's an easy and efficient way of creating that fully compliant certified report that you need to prove compliance for your temp to uniformity survey. So let us see how we can generate a full compliant certified report for a test run that we've completed. In the software, as you'll see in the menu bar, there is a Print TUS Report button. If I click on that, you will see the dialog box, which is basically a dialog which allows you to fill in all of the information to describe the way in which the TUS was performed. And as I've said before, this is designed in terms of the content to comply completely with the AMS 2750 and CQI standards. So basically all of the fields that are included in here will need to be completed to give you full compliance to those standards. The type of information obviously we're going to be putting in is identifying the furnace, the operating range, working volume, whether we're using a loaded or unloaded furnace, the atmosphere used, maybe if it's a conveyorized oven, what the transverse speed is, or what's the conveyor speed into the furnace. There's also some other optional fields that may or may not need to be added, and you can see here that you can tick them on or off to include them in the report. Control instrument tuning constants, as found and as left TUS offsets, and the TUS and furnace recording sensor relocation analysis information if needed. The grey areas, as I've said before, are the data that is incorporated into the report as standard because it's as part of the actual TUS data itself. And that includes things like the actual thermocouple calibration information and the data logger correction factor files or calibration information for the field test instrument that was being used. If I go to the next page now, you'll see that we have at the top, you can put in your company logo. You can call the report by a specific name that makes easy identification for future reference. An important neat feature is the ability to add additional details table. This is where there might be some key parameters you want to report in your survey report that is unique to the furnace you're using or the work you're doing. So you can create a header for a specific parameter, and you can then put the value specifically into that. It might be useful, for instance, when you're trying to monitor the usage of the thermocouples, what the usage rate of a particular batch of thermocouples is for that particular TUS, so you can still be compliant with the usage records and usage levels for thermocouples, depending on whether you're using non-expendable or expendable thermocouples for your TUS. You've got the free entry note section where you can put any additional information you like. To create the report, it's simply a case of pressing the Create Report button, and we will then see the actual deliverables of the report page by page. So here we have our first page, which is basically summarizing all of the parameters that are used for the survey, all of the criteria that was set to do the TUS. The next page is a continuation of that. We then have the actual graphic showing you the 3 TUS levels that we performed, a schematic of the TUS frame that was used for the TUS, showing you where the thermocouples are located with the text descriptions as set up. The next page is for the results for the first TUS. So we have at the top the summary table for the data we're looking at, and as you can see here in the top right hand corner, we even have a summary of what correction factors were applied, what the outcome of the test is, whether there was an overshoot or not, and in this case we've got green ticks, so we're all happy. So we've got the analysis information, including the furnace class reporting. We then have all of the raw data that's been collected to match the data collection requirements of the standard, so 55 degrees below the TUS level. And you can see here that we even indicate what part of the TUS the data is coming from, whether it's the overshoot search, the stabilize, or the TUS data itself. You see this little schematic in the left-hand column to show you where that data is coming from. Obviously, there could be lots of data that we're looking at. Let me zoom out again. Let me go to, so the second TUS at 945, and then the final TUS at 1020. And the last important bit of information is the data relating to the correction factor files that have been used in the TUS, taken from the thermocouple correction factors, and also in the next page the data logger correction factor files. So what you have here is all of the correction or calibration data for the data logger, plus the correction factor that's been applied at the respective temperatures. Obviously, we're using the interpolation, linear interpolation, to allow correction over the whole temperature range. And we also report what the correction factors applied were at the respective TUS levels, so 800, 945 and 1020, which is a requirement of the standard itself. Last but not least, we have our audit trail, which basically shows us all of the steps that we performed. Having put all the information into the template, which is obviously going to take a little bit of a while the first time you do the run, to save time and effort for subsequent runs, we have the ability to save the template. So it saves all of the manually imported complementary data for the report in a single file. So simply call it report template furnace A, B, C. That's now saved, and we can then recall it for future use with ease and efficiency. we've now completed a subsequent TUS, and we want to now generate a fresh report for this new TUS that we've just completed. Obviously, as you would expect, when we go to the reporting options tab or dialog box, there's no entry, no information in here as standard. This would normally be edited manually. But obviously we've already saved the template from the previous run on the same furnace. So all of that information we can copy across. It's easily a case of just picking up the template file. It will auto-populate all the manual fields in the dialogues, and it allows a very quick way of generating a sequential report on the same furnace. Obviously, you're going to create different templates for different furnaces and different TUSs, and it may be necessary that on each of your TUSs you may need to manually edit some of the fields, but the majority of the information is likely to be consistent. Things like the operating range and the working volume of the furnace. Some of the parameters, a little bit of tuning constants may change, but you can edit them subtly within the report. But the template file will save you significant time. And again, we can then generate our new report very quickly and effectively. Creating a library of template files, you can do any number of different furnaces very easily and effectively, and have full control over all of the parameters you're going to report in your TUS documentation. And remember, all of it will then be compliant to the requirements of AMS 2750 or CQI 9.